Alright, before the video starts, I have to admit, I'm by no means a professional, nor am I someone who regularly uses CNC machines to make DIY parts. But after just a few days, I managed to create this, my own mini bust. And honestly, the level of detail is kind of crazy. The folds on the polo shirt, which is actually the one I'm wearing right now, the textures, even the grooves around the arm. This is something a normal CNC simply cannot achieve. And if that's not enough, take a look at this impeller and this CV joint star. These parts have deep curves and hidden angles that 3-axis or 4-axis machines just cannot reach. But with the 5-axis CNC, the tool tilts as it cuts, so it can get into those angles and finish everything in one go. This kind of geometry is only possible with 5-axis machining. And if you think that's only for factories, think again, because right here is the XMachine WM-100, a true desktop 5-axis CNC. It comes with a 1.5 kilowatts, 20,000 RPM spindle, a dual cooling system, air and mist cooling, automatic tool changing and probing, and plus or minus 0.01 millimeter repeatability. It can cut everything from aluminum and wood to titanium, stainless steel, even jet. But what really stands out is how easy it is to use. No CNC programming, no Fusion 360 experience, no problem. XMaker turns text or STL files into ready-to-run toolpaths. So in this video, I'm going to break everything down and show you why this might actually be one of the most accessible 5-axis CNC machines out there. As always, if you want to learn more, check the link in the description. By the way, while I was filming this, I had a surprise visitor at my studio, all the way from New York. My friend Aker. He's a long-time traditional CNC user.
Now this is a special part. Oh my god.
Yeah,
that's so cool.
Okay, just saw this. So he'll be sharing his first impressions of this machine. No script, just real thoughts. And hopefully answering some of the questions you might have. So stick around till the end. Without further ado, let's get started. First things first, let me give you a quick design walkthrough so you have a general idea of what you are looking at. So up here is the HMI screen, fully touch screen and super responsive. All the main functions are laid out right here. A tool setting, workpiece positioning, program execution. Everything is key and easy to navigate. Below that is the control panel. Now I know what you're thinking. Look at all these buttons. But honestly, it's way simpler than it looks. This knob here is for selecting the mode. MDI, jog, or auto, stuff like that. This one controls the feed rate. And this one controls the spindle speed. And these buttons down here, mostly self-explanatory. The lamp turns on or off the light inside the machine. This one calls off the tool changer and starts automatic tool changing. The heading tool magazine pops out, holds up to 6 tools. The spindle drops the old tool and picks up the new one you selected. And then the magazine retracts, all at the press of the button. I'll show this more when we use it in real CNC machining case. This button turns the air blast on and off. Now, this knob over here, it selects which axis you want to move. Once you're in jog mode, just rotate the handle wheel and the corresponding axis moves. Check out the A and C axis. A tilts the cradle forward and back, and C rotates it vertically. Together, they let the tool reach angles and curves that a normal 3-axis machine could never touch. The way the cradle moves, coordinate both rotations and linear motion, it's mesmerizing. You can literally watch the tool dance around the part, reaching curves and undercuts that a 3-axis machine could never reach. So yeah, the control button looks intimidating at first, but trust me, it's actually really easy to pick up. You'll get comfortable with it in no time. Move to the left, we have the transparent machining compartment, so you can watch everything happening in real life. Normally, when it's machining, you need to close both the front and top windows to prevent dust flying. But for this video, to give you the best viewing experience, I left them open, exposing my expensive camera gear to all the dust. So yeah, definitely give my channel a subscription to support my videos. This one's for you. One important thing you might be wondering about is the machining size. Well, it actually depends on how you're using the machine, so I just put it on the screen. Also, just so you know, if your workpiece is taller than 80mm, auto probing won't work. Yes, the machine comes with auto probing, and it's actually really cool. It can automatically detect the exact size and the position of your workpiece, set the 0 point, and even calibrate the tool length, all without you touching a thing. This is what makes setup so fast and accurate, especially if you're doing multiple parts or switching tools. But for taller parts, you have to do the tool setup manually, just like I'll show you later. And size-wise, I was actually surprised. It lands at 797 by 614 by 580mm, which is much smaller than expected. If you do some research, you'll see traditional 5-axis machines are much larger, super heavy, and usually require special power and a dedicated foundation. But the XMachine WM-100, you just put on a desktop, and that's it. And that's the design walkthrough. Now about the part everyone cares about, how to use the thing and how it performs. For this section, I show you on-site recording, nothing scripted or post-edited. You'll see my step-by-step operation, the process, the noise, and real-time machining. Now, let me just show you how to make a finished product from scratch by using this XMachine. Let's start from the software XMaker. Alright, so this is the interface of the XMaker. It looks really clean, and I'm not going to show you like every step, everything, but I will just show you some key specs. Alright, they offer AI tools, which text to image, just input whatever prompts you want, and then also they have the model generation, which lets you just import the pictures you want to generate a model. Here, let's just import the model. We go to Cam and click Stock. Here is the size, the dimension of your workpiece, and you can adjust the length, width according to your real size of the workpiece. Okay, here mine is 100. I will need to change to 100mm, and that's it. And this is Q-boy, right? Okay, add, and then we choose material. Since mine is like wood, so we choose wood. But if yours is like brass or steel or aluminum, just choose like. And then the software will match the best machining parameters for you, so you don't have to adjust manually and this and that. Quite intuitive. And then click select. And now let's import model. Currently the software only supports TL file, but there will be more files later. Alright, so this is the file we just imported, and you can drag, enlarge, zoom in, zoom out to see the details a little bit. What's more importantly is you can double click on the model, and then here you can resize your final product, resize it. But for us, just use the original one, and if you don't know which size it's in, just click reset. Okay, this is the original one. It should be the best for your model, and that's it. Alright, now click technology. You can see the feed, the spindle, allowance, those parameters is already matched because you have chosen material before, right? So you don't have to adjust anything. Here, auto cut off means if you want your finished product to cut off directly, and then you just check that and confirm. And now go to last step, generate toolpath. For any CNC users, toolpath generating is like the most complicated part. You have to learn software or something. But here in the software, which generated toolpath for you automatically, just click and the machine will start. Alright, toolpath calculation finished. It took about 3 to 4 minutes, and then we click confirm, and then enter this toolpath simulation stage. And it gives you this whole process, like it simulates all the machine process, so you will know whether your final product is good or not. All right, this is a limited time consuming if you want to see all the process. Here we just pause it, and then we exit. And now we go to G-code generate. And here we have 3 output options. We just choose the first one. That's it. Generate G-code basically means you translate to the language that this machine understands. Okay, we just click generate G-code. Alright, now the G-code successfully generated, we just confirm. And yeah, here I want this. we don't need to know all of this. The machine understands. And here we have the simulation button, which is also very important. You click and then the machine will simulate the whole process, so you will know if it will collide or something, which makes your whole process much safer, and you don't want to waste your material, you know. Alright, now the machine simulation is finished. Let's confirm. Let's go to next step. We go to AutoCAM, click upload, and then we upload all the G-code to the machine. You will see the process. Alright, that's it. And then we go to the display and we can check the local file. It should be there. We see there's 4 files. Alright, we choose the file and then we load the file. File loaded successfully. And then you can see all the G-code information. Now we load the workpiece. First, we have to level the cradle by crank this. Great, and that's it. And then we fix it. Now, with that fixed, let me show you how the tool changer works, because this is one of my favorite features. I gotta show you good. The machine has a built-in tool changer that holds up to 6 tools. Right now, it's all loaded inside. I just hit this button on the control panel and watch. The tool changer extends out. Nice and smooth. And then the spindle will select the right tool automatically. Oh my god, that's kind of like magic, right? And now to the tool setting. Go to machine, it's already in the tool measure, and then we click measure tool. Okay. We see the machine automatically measures the tool length, sets the offset, does everything for you. Next up, workpiece positioning. You can choose different shapes for the workpiece. We're gonna go with the cuboid. Now, there are 2 ways to do this. You can see the wireless probe, which is super convenient. It automatically finds the center and is very accurate. But because this workpiece is a little big and the probe has a limited range, I'm gonna use the tool itself for positioning today. Click on tool measuring. You see the diagram on the screen. It shows me exactly what to do. I need to move the tool to 5 different points on the workpiece, and the machine records the positions. It's basically telling the machine, hey, this is where my part is. So I go point by point. You have to make sure the tool slightly touches the surface, but no extra cutting. The screen gets me through each step, so don't worry about that. Super easy, even if you've never done this before. Once all 5 points are set, I just hit set 0 off. And the machine now knows exactly where the workpiece is. Before the final machining, I want to introduce the third method, optical centering. And this one is truly incredible. On top of the machine, there is a built-in laser scanner and camera. After you click start positioning, the scanner emits laser lines, and the cradle rotates through a few angles. And just like that, workpiece position is complete. This is probably one of the easiest and smartest ways to set up a workpiece I've ever seen on a CNC machine. Alright, that's it. Now it's time for the real magic. I hit the start button and let the machine do its thing. Alright, as you can see, the roughing has finished. And now it's about to change the tools automatically. You see, the tool changer just pops out, removes the current tool, grabs the next tool, and puts it back in. Wow! That is smooth, right? No stopping, no manual swapping. The machine just handles it. Yeah, that's it. So you see, that's why having the tool changer is such a game changer, because it happens all automatically and you don't have to sit here like an idiot. And that's the epoxy tooling board machining. Like I mentioned at the beginning, The level of detail is just insane. Honestly, this is some of the most detailed CNC work I've seen so far. But don't just take my word for it. Let my unexpected guest, Aker, she has thoughts on the engraving results, so it doesn't sound like I'm just bragging.
This is super cool. I didn't know that you had such a strong double chin. It's awesome.
Yeah, what do you think about it, Aker?
It's very impressive. Not only did this machine, it was able to get this little impression on your shirt, on your chest, but the divot that your arms make, it's very special because it's only possible to be created on a machine such as this. It's only through the A and the C that we're able to get up in this part and dig out this material. So that's really, really cool. The resolution of, was it 0.01 millimeters?
Yeah. Plus or minus.
Plus or minus. Yeah. You could tell that this is totally acceptable if you're doing rapid prototyping.
I also did a CV joint store. The little store inside the ball bearing CV joint. This one was cut straight off the cradle. No post polishing, and it feels super smooth and refined. No sharp edges at all. If you look really closely, you can even spot the tiny cutting marks. The reason this part can only be done on a 5-axis CNC is all in the geometry. Those hidden angles and deep undercuts, a normal 3-axis or 4-axis machine just cannot reach them. With 5-axis machining, the tool can tilt and rotate while moving along the part. So it can cut all those complex curves and finish the piece in one go. No extra setups, no flipping the workpiece, and no compromises on precision. And if you're worried about the stainless steel, well, I tried it for you too. Check out the 303 stainless steel knuckle. Again, the level of detail is insane. The lion's nose, the patterns around the finger holes. Honestly, I'd say this is reaching artistic level. I think that's it. Here are more of the finished engravings we've been testing over the past few days, and honestly, I keep asking myself, what can it do? And with that, let's move on to the conclusion. So overall, after spending a few days with XMachine WM-100, I have to say, it genuinely surprised me. Not just because of the 5-axis capability, but how accessible it makes something that used to feel very industrial only. The level of detail, the ability to handle complex geometries, and the automation. It really lowers the barrier for people like me who aren't CNC experts. I mean, if I can make all this, you can too. Let alone the hardcore CNC guys. That's it. It's not perfect. The working area is still relatively limited, so you won't be making huge parts. And while the software makes things easier, there's still a learning curve if you've never touched CNC before. Also, for tall workpieces, those auto-probing can slow things down a bit. On top of that, this is a crowdfunding product, so it might take some time to get to you. But thinking about it another way, the price-to-value ratio could be insane. For a desktop machine, what it offers is kind of mind-blowing. If you're a maker, run a small studio, or just want to explore real 5-axis machining, this is definitely one of the most interesting options out there right now. And if you're curious, check out the link in the description to learn more. Oh, and if you want some outside perspective, my unexpected visitor Aker, a hardcore traditional CNC user from New York, shares his first impressions and highlights the differences. Stick around and hear what he has to say. You might find it really interesting. What kind of a CNC machine you used before?
I've only used a 3-axis at home. You know, I machine simple parts. And for more complex geometries, you'll have to send it out to a place when they have a big 5-axis machine, right? And you have people who have to program it, and you wait. The lead times on that, you know, it might take 2 weeks.
2 weeks,
right?
Yeah.
2 weeks, a month even. In the States, they're very busy right now. So I think this would be perfect for someone at home like me. Sponsorship, hit me up. But like me, who would want to do rapid prototyping and really save on that temporal cost, right? It's not just about the dollars that you save, but it's about that time that you're able to quickly iterate through your ideas, right? And the fact that this can do stainless steel, it is like very exciting, because that just shows your spectrum of possible projects is super broad, right? And like right now I see on this is a touch screen, right?
Touch screen.
Super cool. I see different end mills on the screen. You're telling me that this also has an automatic tool changer.
Yeah.
And there's six tools that you can load.
Oh my god, yeah.
Yeah, so
happens all
that's gonna help with your process, because I'm used to CNC machines with no automatic tool changer. So I had to manually go in, take out the tool, put it back in. I got to recalibrate it. It's a pain. It's an extremely tedious process, because I have to wait. Sometimes I have to wait till it gets to a part. Think about it. You did this part. You just put it in, did some calibration.
Yeah.
And how long did this take for you to do?
This is about like 2.5.
2.5 hours for this?
Yeah, for this.
So can you imagine that I was trying to do this part without this tool changer, and for 2.5 hours, let's just say I did have 5-axis ability, but I did not have a tool changer, and this part required even 3 different end mills to do. I would have to come back every 40 minutes. So I would have to leave and then come back 40 minutes, and it would stop until I changed that part. And I have to calibrate it again, and I leave and come back. But for you, you could just set it up, press play, and then you end up with this. It's super cool.
Yeah, fast.
Fast and accurate.
Accurate.
It just looks so refined already.
Yeah. Crazy, details, everything.
Yeah, and for the end mills, for the tooling, you're telling me, I heard the word on the street was these are not proprietary. Like, we're able to buy any standard end mills and use it in this machine. Yeah, that's correct.
That's right. That's right.
So that's really cool. So it's apparent to me, like, X-Horse is not trying to lock you in and trying to sell you on the tools. I think they're really trying to make a good product that helps with your productivity, and not trying to make money on like the consumables. They know that the consumables are gonna break, they're gonna get dull. And for them, they're just like, okay, let's just make the system very user friendly. Yeah. So that's really impressive. I also just have another question. What type of power does this require?
So the power is 2.2 kilowatts. So basically like a hair dryer, using like.
So this machine, I can just plug it into my wall in America. And it will function fine. I don't have to install other breakers in my panel, right? Yeah. Which is really cool, because if you buy a 5-axis CNC machine, like a big one, you're gonna have to, you might have to have really powerful electrical system, Oh, I think one of them, also a point that I think needs to be made is this machine does not connect to the internet if you don't want it to. I can use an SD card to put in the G code.
USB drive.
USB drive here.
Oh, okay. SD card. I'm dating myself. You can see like when I started doing this stuff, right? Okay, USB drive, you put it in here. Okay, that needs to be emphasized. This machine can operate without internet connection. So you do not have to register an app.
So I got last question. What's the most exciting part for you about this?
Besides the fact that this has a tool exchange and a 5-axis CNC function, I think the thing that is the most important to me is I have the option to operate this offline.
Yeah.
I do not need to connect it to the internet for this to work. Right now, it's too many tools, too many maker tools or any of our consumer electronics need us to register a profile, give them all of our data in order for us to use something that we bought and own, right? The fact is we can have the choice of connecting it to the internet, which is really cool, because they're gonna have they have a camera in here that enables us to not only keep an eye on the work as it's being done over the internet, of course, but it also does analysis. So it's gonna be using lasers to be analyzing the part, and I'm assuming to make it, to enhance the quality of it, and also if there's any catastrophic failure, the machine will probably stop. So before anything else happens, right? That's really cool. The fact that, again, it does not need to be connected to the internet. So I really applaud X-Horse for that. I really hope going forward they keep this ethos, because as consumers all over the world, we need to have the ability to remain private and keep our data for ourselves, right? Unless we choose to not. That's why I think right now it's exciting. It's going to be a Kickstarter, right?
I think it's going to be next month. This is going to be a game changer. What do you think?
Yeah. So I can take this home, right?
You can steal it. So maybe next I go to New York, you hook me with something?
Yes, I will.
Okay,
yes.
thank you.
Yo, keep making it.